How's it going, you guys? It's Scott with the Everyday Home Repairs. Now, if you're doing DIY electrical projects around the house, sooner or later you're gonna run across something like this, which is a damaged piece of Romex. Now, whether that was already there or you actually made a mistake and damaged it, either way, you need to correct that issue and do not just reset your breaker and go on about your day, acting like there's no issue. In this specific instance, you can see the hot conductor is exposed now right next to the ground, and that can cause an arcing situation that can be obviously an unsafe scenario that you do not want in your own home. Now, I just made a mistake up in my attic where I was drilling through a double top plate and I did nick a 14 gauge 2 conductor piece of Romex, and now I need to fix that one, and also I'm gonna fix another strand up in my attic. So the fix I'll do in the attic is my preferred method, but is only one of the 3 ways that I'm gonna demonstrate. And one of those is the only thing I've seen that is approved to be in your wall without access. Now this is approved, but is it safe? So we'll actually be testing that, running 20 amps through it for 30 minutes and taking temperatures to see, can it actually handle that? Because for me, this design is a little bit questionable. So let's go ahead and jump in the attic. We'll get my issue fixed, and then we'll jump back to this one to do the in-wall scenarios. So for the attics and basements where we have access, I would prefer to install a junction box. Now, some people would prefer plastic. I do go with metal in basements and also in attics. I just think they're more durable, and I prefer them so I can put my cable clamps in there and securely hold the Romex. Now, if you have your damage in a wide open spot, you might be able just to splice that wire in without adding any additional wiring. I do recommend these inline splices from Wago. These are lever nuts. You can cut your Romex, strip it back, insert one end here, insert the other, close your levers, and now you have your secure wire connector between those 2 pieces of Romex, and you have that damaged part out. That is handy when you have no additional slack to pull in, but don't forget, you still need to have those within a junction box so they are code compliant. For me, my damage is actually in the double top plate in the 2x4 at the top of the wall, so I need to pull a new piece of Romex. Now, pulling this new wire is going to be kind of the hardest part of the job. You need to find your Romex, and then now you want to use that existing piece of Romex, the damaged one, cut it back to where you want that junction box to go, and then wire in this new piece of Romex to the old one. Just using your bare grounds, you'll connect those together, double them back, and make sure they're secure, and then wrap the whole thing in electrical tape to make it as smooth as possible. And then this is kind of a 2-person job. One pulling in the attic, one kind of pushing up through the box, making sure it's not contacting anything it shouldn't. But this is not always going to work for you. In some instances, you might have a staple on the stud and it's just not gonna pull your new wire up and through. So if using the old Romex to pull in the new Romex doesn't work for you, you're gonna have to use electrical fish tape. In my case, I used fiberglass fish tape, which I do recommend, especially for DIYers. They're gonna be fishing into an electrical panel. It's just safer and non-conductive, but it also might be a 2-person operation. Now, you'll see a link to this fish tape along with those Wago lever nuts, the hybrid wire strippers from Knipex I use, and my favorite multi-bit screwdriver, which is the Klein Tool 16-in-1 that has all the bits you possibly need with a small handle. And most importantly, I can bring my impact driver up there and use this not only in the screwdriver, but also in my impact driver, so I don't have to bring up my Milwaukee Pack-Out bit kit. I have everything I need just in one screwdriver. Now, something that might also help you out in locating that fish tape, if you have a small slit cut right at the top of your electrical panel, that will give you visibility to where the fish tape's at, and the cover will still cover that, so you're not gonna see that gap once the cover's on your electrical panel. Then once you have your new wire connected up, again, a 2-person operation is preferred, and then hopefully it pulls right up into your attic or your basement, so now you have your new lines that you can connect up in the junction box. So now up in the attic, and this would be the same for your basement, we have our new 14-2 Romex coming in. I have 2 circuits, you might only have 1. There's the 4x4 junction box. If you just have 1 circuit, you might use a small handy box. And I'll start off by securing that junction box to the joist, and then bringing in the Romex here, the 14-2, and this is my first circuit. I did label my circuit since I have 2 pieces of Romex just to make sure I don't get them mixed up. Securing that first one, And my wires are a little shorter than what you'd want. Usually, according to code, past the sheathing that I just cut off, you'd want 6 inches and at least 3 inches past the edge of the box. Now I'm just using the inline WAGO splices. Remember, a link in the description for your reference for the hot and neutral, and then that 3-wire to bring together the pigtail, which will ground the box. Now in the second circuit, something very similar, but in this case, I'm just gonna pass through the hot, the neutral, and the ground. So we'll just be using the inline splices on each one of those and tucking them back inside the box. Once we get that, then just put your cover on and you're ready to go down to your panel and start making your connections. Now remember, working in the panel, most of you are gonna have a 100 amp or 200 amp breaker, the main disconnect, and you want to turn that off, but the main conductors coming in are still live coming from your meter base. So be careful flinging around wires and bare grounds as you put these new circuits and land them on their appropriate breaker. In my case, I do have a main outside, so these conductors can be de-energized, and it's pretty handy when working in the panel. So we already got our first one landed. I'll strip down that sheathing, cut it back, and then route my ground first. Always best practice to land your grounds and then move on to your neutral and your hot. And then just take your time measuring, trying to keep it as clean as possible. It doesn't have to be perfect, but if you keep it clean and tidy, it'll make your next job that much easier. So what about option number 2? So 2 and option 3 are gonna be for in the wall damage like what we have going on here. The second one is approved to be buried in the wall. Now, when I asked my community, is there any splicing kit that is NEC approved and can be buried? About 7 out of 10 people either said no or they weren't for sure. So these type of products are not well known and they're kind of hard to get. And it's a splicing kit made by a company called NSI. Now I'll install this right here and we'll actually do some testing. The way that you install your wires in these is not my favorite, and it's a little bit more like Ethernet cable than something that's gonna carry 20 amps. And I think that's where a lot of the skepticism comes from, at least from my side, and I would assume some of the professionals and our other viewers over time. I've installed one of these before on another project and documented that on the channel, but this time we're testing it. I did a baseline test of this 12-2 Romex with no issues and no splicing kit to get the baseline of how much did that wire heat up as we loaded it up to 20 amps at 120 volts or 240 watts for 30 minutes. Every 5 minutes I took a temperature and we did see it plateau, so it was able to reject that heat just as much as it added it from the load. So that's good to see, but what will the splice do? So let's go ahead and install that, do the test to see how hot it gets so you guys can be informed for your own project home, and then we'll do the third option that might work best for you. So here's how the NSI Romex Splice Kit works. We're gonna go ahead and install a half on each side, and then those will clip together to complete the circuit. Now you'll see they have these little forks. Those actually pierce the insulation and make contact between that fork terminal and your actual copper within your conductors. That is not what I love, but that is the design of these splice kits, and the testing will show us if that increases the resistance and causes a lot of heat, which might lead to failure. Now, one thing I didn't do, you can leave your hot conductors a 1/4 inch longer than your ground and your neutral, but I'm cutting back the insulation. And really, you don't have to strip your wires. Remember, we're going to press them in and the forks will pierce the insulation, making contact between the terminals and the copper in the conductors. So the way you do this, you just take your pliers and not too aggressively pinch that top casing on, and then there's a little cradle that presses that wire on each one of the forks. And then the screws actually do not go through the clear side, they go through the white housing side to make sure it pulls everything together and it's tight. Once you have that, all you have to do is plug each side together and you have your completed circuit, and now we're ready to start our testing. So I'm going to tape on with painter's tape right at the fork terminal, a K-type thermocouple that will run into my clamp meter here, and it'll give us a degrees Fahrenheit. I'll run it for 30 minutes. I ran that baseline for 30 minutes. Now we'll run the splice at 30 minutes so we can compare, taking temperatures each 5-minute interval, and then we'll be able to compare the curves to see how much different the splice is compared to our baseline 12-2 Romex. And then I'll just plug that into a portable power station that can easily deliver the 2400 watts and then crank up 2 heat guns to pull that load. So I finished up the testing, and now am I less or more confident in the splice kit design? I was a little skeptical going in. Now again, we ran the baseline for 30 minutes. We started at 64 degrees Fahrenheit and we ended at 96 degrees Fahrenheit just on the 12.2 Romex for 30 minutes, taking a sample every 5 minutes. We increased heat, but we started to plateau there at the top. Now for the splice kit, I was extremely impressed that overall the ramp and the heat, we started off much higher at 77 degrees Fahrenheit and we ended, although higher than the Romex, at 100 degrees Fahrenheit. The ramp rate was about the same. It started to plateau and it actually added less heat compared to that lower start point that we saw with the 12.2 Romex. So overall, this installation, 30 minutes, 20 amps, it was able to handle it. It is not a dangerous situation. Let me know what you guys think down in the comments. Now this is 12.2 Romex. There might be more issues with 14.2 Romex, although you're gonna have lower loads because the smaller diameter, remember those forks are the same. So maybe there is opportunity when you press the housing together that it doesn't fully pierce the insulation, so you do not get solid contact between the terminal and the copper. So maybe there is a heat point because I have seen these type of devices fail in the past. Now you might think that design is insane, no one would ever use it, but just know there are self-contained devices used in the RV industry and the manufacturer and mobile home industry that a lot of the outlets and light switches, it is exactly this type of format. You have your junction box and your outlet or light switch built into the same unit. And then when you take this housing off the back, you can see those forks in the conductors and the ground, the way they make contact is exactly the same as the splice kit. Now, I have personally seen these fail. I had a double wide manufacturer home I rented out there for a bit, and somebody plugged a griddle into a kitchen outlet, and that did actually fail that outlet. So I have seen this type of device fail, and there can be issues, but just know these type of devices are being used. Still not my favorite, but they are out there in different applications in the industry. So what about that third option? Let's quickly review that, and hopefully this gives you what you need to fix your problem at your house. So for this last instance, maybe we're trying to fasten something to the wall and we tripped a breaker. So we turn the power off and we need to figure out what's going on. So I'm just gonna cut a little exploratory hole here so I can see inside the wall. If you have a scope, maybe you just have to drill a hole and you can scope the backside of the wall. But for me, I do see that damaged Romex right there, and we're gonna need to fix that. So what I'm gonna do is use a 2-gang old work box and cut that into this exact location. It needs to be lined up because we probably don't have much slack in these pieces of Romex unless you have a close service loop that you can pull through. So just cut that open and try to feed those through into the 2-gang box. You're most likely going to be limited here. If you're very limited like I am with the Romex, go ahead and take the old work box back out and let's go ahead and strip away the sheathing and strip away the insulation from the neutral and the hot conductors so we're ready to go once the wires come into the box. Now, with those wires so short inside the box, what are we gonna do? Well, here's where those Wago lever nuts really shine. And I don't even know how you would do these without the inline splices. And you'll see that link in the description. And if you're on your TV watching, you can actually take a picture of the QR code and it will take you to the complete list with the Wagos and all the other tools we're using. So we'll just extend out these pigtails. We have the one piece of Romex done, and we'll do that to the other side. Remember to do pull tests on each one of these to make sure you have a secure connection. And then I'll take standard 2-wire Wagos to bring those together. Remember, you could install an outlet if you wanted to in this location, but I'm just gonna put a blank to cover up our repair because now we have a safe repair. Now let me know down in the comments, do you prefer number 3, this technique, or that splice kit on number 2 that we did earlier? And I do encourage everybody to go down there. There's always a gold mine of information, other opinions, and additional information, which in turn will just educate you more for your own projects. Now, I want to help you avoid the most common mistakes, and you can check this video out right here. We'll run through the 5 most common DIY mistakes, which will help to keep you safe while you're taking on those projects, saving time and money. So thanks for joining me on this video, and I'll catch you on that next one. Take care.